Knowing how and when to apply the correct constraints in Fusion 360 is very often what separates a good parametric sketch from a great parametric sketch. In this tutorial, we're going to take a closer look at each of the 12 constraints. After completing this tutorial, you'll be able to apply constraints to sketches in Fusion 360. In order to begin this tutorial, you'll need to have open the file named Constraints from the dataset. With the correct file open, you first need to expand the sketches. There's a number of sketches in this file, each labelled and corresponding to each of the constraints that we can apply in Fusion 360. And during the tutorial, we'll be toggling on and off the visibility of each one of these sketches as we work through the exercises. To apply each constraint, we'll need to double-click to edit each sketch. So let's do that, and let's begin with the coincident constraint. The coincident constraint applies position continuity between two selected objects. To demonstrate this, in the sketch palette here, we have our constraints. If I click to activate the coincident constraint, and then select the centre of this circle and this line, we've now applied position continuity between the centre of the circle and the line, and no matter how much I pull this circle around, it'll always be fixed to the line, or the infinite extension of the line. Let's take a look at the collinear constraint. The collinear constraint makes two lines parallel, but as well as making them parallel, it also ensures that they share one common line. So if I activate the collinear constraint, I can demonstrate this. If I select this line and this line, you'll see that not only are these lines parallel, but they also now share a common line. And no matter how much I move this line or the rectangle, both lines will always be parallel and always share a common line. The concentric constraint aligns the center point of circles and arcs. I'll activate the concentric constraint, then select this circle and this arc, and I've now aligned the center point of both the circle and the arc. And if I try and move it around or edit it, no matter what I do, the center point of the circle will always be aligned with the center point of the arc. The midpoint constraint can be applied to a number of different sketch objects. So for example, if I activate the midpoint constraint, I can select the center point of this circle and this line, and now if I try and move these, the circle will always remain at the midpoint of the line, no matter where the line moves or how long the line becomes. If I use the constraint on this point and then click the line, no matter where I move this line or how long the line is, the point will always remain at the midpoint of the line. We can even align the point of lines with other lines. Whilst the angle of the line may be adaptable, the point of the line will always remain at the midpoint of the second line. And finally, we can align the midpoint of two lines. I'll select the right-hand line on this square and then this line here, and they snap together to share the same midpoint here. No matter how we reconfigure the square or the line, they will always share the same midpoint. Now let's take a look at the fix-unfix constraint. The fix-unfix constraint is pretty straightforward, in that it locks or unlocks selected geometry. So if I activate fix-unfix in the sketch palette and then select this line, we can see it turns green to indicate that it's now locked. Now if I drag this triangle to move it, we can see that the line is fixed. This line is not fixed and moves freely. If I place a fixed constraint on this point of the line, when I try to move the line about, we can see the point is fixed. And if I unfix the line on the triangle and use my mouse to grab the corners, we can see that it's now free to move about. Now let's take a look at the parallel constraint. The parallel constraint is a pretty simple constraint to apply. It makes two lines parallel to each other. And this is easy to demonstrate. If I activate the parallel constraint in the sketch palette, select this line and this line, these two lines are now parallel. I can do the same with this line and this line also. Let's take a look at the perpendicular constraint next. The perpendicular constraint, again, is fairly simple. It makes two selected objects perpendicular, or meet at a 90-degree angle. If I activate the perpendicular constraint, then click to select this line and this line, we can see that these lines are now perpendicular to each other. Even if I use my mouse to move the line about, with the constraint applied, it will always remain perpendicular to the other line. If we wanted these two lines to touch, we could also apply a coincident constraint to them. Now, if I move the rectangle or the line, we can see that not only are they perpendicular to each other, but they're also fixed at this point. Next constraint is horizontal-vertical. The horizontal-vertical constraint makes two objects that are selected horizontal or vertical to each other, depending on which is the closest. So let's first activate the horizontal-vertical constraint. And let's select the center point of this circle and this circle. Now these two circles are vertically aligned according to their center points. We can still make edits to them, but with the constraint applied, their center points will always be vertically aligned. We can also apply the horizontal-vertical constraint to lines and points. So for example, if I select this point on this line, and then the center point of the lower circle, when I move the point on the end of the line, we can see that there's now a horizontal relationship with these two objects. Next up is the tangent constraint. The tangent constraint is similar to the coincident constraint, but rather than just positioning two things together, it also ensures that they have a continuous surface between them. So let's click to activate the tangent constraint. Then let's click the circle and click this line here. And the circle is now tangent to the rectangle right-hand line. If we wish to, we could also select the circle again and the left-hand side of the rectangle to make the circle tangent to both sides of the rectangle. We can also apply the tangent constraint to the circle and the line by selecting the circle and the line point. And now we can see that the line is also tangent to the circle, and as such, it shares one continuous line with it. Let's take a look at curvature. The curvature constraint is a little like tangent, but it's much smoother and applies G2 continuity. To show you what I mean, let's create a spline. In the toolbar, click Sketch, Spline, and sketch a spline from this corner to this corner. Okay, let's activate the curvature constraint. Now let's apply curvature by selecting this line and the spline. Select the spline again, and then the top line on the second rectangle. Let's take a look at the equal constraint. The equal constraint makes selected objects equal to each other. Let's activate the constraint from the sketch palette. If I select this top line on this square and this top line on this rectangle, these lines are now equal distance to each other. I can also make this line and this line equal. And if I grab the top corner and move one of the squares, both squares remain equal to each other. I can select multiple objects at once, then click to apply the equal constraint to make them equal size. And if I want to edit the size of one of the objects, the other objects remain equal. Our final constraint is the symmetry constraint. The symmetry constraint makes objects symmetrical about a reference point. Let's activate the symmetry constraint. And let's say, for example, that I want this line and this line on this rectangle to be symmetrical about this line. With the constraint applied, no matter where I move the line of symmetry, or what edits I make to my rectangle, the rectangle will always remain symmetrical to the line. Let's see what happens when I apply symmetry to this line and this line, using this line on the rectangle as my line of symmetry. I've now created multiple symmetric relationships between these lines and rectangles. And these kinds of relationships can be really useful in sketches. But on occasions, we may wish to edit our constraints and remove them completely. We can do this easily if we hover over, select the constraint icon that we wish to remove, and then simply delete it using our keyboard. I've just removed my symmetry constraints. And now if I grab the objects and move them around, we can see that there's no symmetrical relationships between them. This concludes our tutorial on constraints. In the next tutorial, we'll be looking at how we can construct planes, which we can use to create sketches in three-dimensional space.